ecosystem is the next spatial scale down, or smaller in scale, if you will, when we talk about biodiversity. So we go from biomes to ecosystems, and the term ecosystem is extremely elastic and dynamic, and we can call the entire planet an ecosystem. We can discuss in terms of scale the rainforest in Brazil an ecosystem. We can go down in scale and discuss the Chesapeake Bay as an ecosystem, or Poland woods as an ecosystem, or the moss on the side of a tree an ecosystem. The scales are really broad based on the primary species that you're encountering and what lens you are examining things at. And for non-ecologists or non-biologists, that could be really frustrating, because we'd like to have things much clearer. But these scales of difference in ecosystems is really important for ecologists, because we learn that there's what we call nested hierarchies in terms of sensitivity and importance of species. And if I was to give one example, would be the white bark pine that occurs at high alpine areas. It's a single species, and the ecosystem in that tree, and more particularly it's the roots of that tree. The tree has a symbiotic relationship with some microorganisms, and those microorganisms only occur in amongst that tree, and that relationship is really tight. But in order for that tree to exist, not only do those microorganisms have to be there, but it is dependent upon specific bird species to bring seeds into those areas to allow for these trees to germinate. So the nested hierarchy would be, we've got a very small condition, only centimeters in diameter, where these microorganisms exist, to then the next scale up, which would be the tree itself and all of the organisms, the insects, the rodents, the bears that scratch on these trees, the birds that come in, are all interacting with this particular tree. And then ultimately the individual birds, which are dropping seeds and have this relationship with the germination and the health of the tree on the other extreme scale, that this bird and its species and its range extends over hundreds and hundreds of miles. So scale then has to become very elastic for the ecologist to recognize the importance of something that's micro in size to something that's macro in its habitat extent. So with that, then ecosystems sometimes can occur within a biome and across biomes, depending on which organisms you're looking at. Organisms such as cougars, mountain lions, for instance, can inhabit multitudes of biomes. And we can look at the multitude of ecosystems that they inhabit as a result. So there's another example of the relationship between a biome and ecosystems. So for the most part, if I was to encapsulate what I'm saying here, is that a biogeographer or an ecologist is going to define an ecosystem based on the primary organism of investigation. And so when you look out on a landscape and you say, oh, I see a bunch of trees and they happen to all be maple trees, if you called it a ecosystem that's a hardwood forest or a maple ecosystem, maple tree ecosystem, you would be correct. So with that, ecosystems have this translation of energy from one very clear system to another system. And as we said, those transitions are based on limiting factors of moisture or temperature, light. We can be looking at nutrient or energy flow from the sun. All of these things change. So I've got a couple of I've got a satellite image here where we've got something called an ecotone, and an ecotone is the transition zone between ecosystems. And we've got Mount Hood, which is a volcanic cone in Washington State in the Cascade Range. So here's the top of this mountain. The cyan color is some snow and ice. I've got the alpine area, and then I've got the tundra area that is delineated through here. And mostly now what we see from here on down is a lot of nice green vegetation, and for the most part it looks pretty uniform. We've seen a couple of bare patches here and there. When we're crossing between this nice rich forested landscape into the desert landscape, in this case it's the Oregon Desert landscape, we've got a transition zone that extends many miles, and this ecosystem allows the species that are in this forested environment to extend rather deep into this desert environment because all the conditions are right for them. These species could be at the edge of their limits of tolerance. Like they might just be getting enough light, or they might just be getting enough moisture, but that just enough allows those individuals that are there to exist. Likewise, the desert is extending towards Mount Hood. So we've got pockets of deserts that are injecting towards the west the same way we've got pockets of forest extending eastward in this environment. So very broad ecotone here, but then we can scale down to ecotones that are within an ecosystem. So we could look at the patchwork here where we've got some sort of vegetation condition that's unique in this part of this forest, and then we've got thicker vegetation here, and there's a transition between the two that is occurring within here. In fact, this is kind of interesting because we can see a mudslide or lahar that's coming down off of Mount Hood in this location. Another ecotone environment is occurring here. You can see I've got a ribbon of conditions of vegetation here, little thicker vegetation on one side of different species and a little different thicker vegetation on the other side. So we've got an ecotone transition that occurs this way across. So ecotones can exist at different scales. Really nice example of an ecotone is this illustration down here where we've got a deciduous forest and a grassland prairie, and we could have a number of different species here, species A, species B, D, E, F, and so we've got all of those, A, B, C, D, E, F over here. As we move out towards the prairie and the vegetation starts to change because the moisture level diminishes, we might have only A, B's, and C's of this species here. Out here on the prairie, we might have species W, X, Y, and Z. And those all occur here, but as we're moving in here, we may only have W and X. So we've got a middle zone of moisture here where it's too much moisture for some of these grasses, but not enough moisture for some of these trees.